Okay, here's the video lesson for lesson 915. And in 915, we are going to practice the ratios of similarity, meaning that we are going to practice using linear scale factor, area scale factor, and our new volume scale factor. If you remember lesson 914, we introduced the idea of a volume scale factor by just investigating what's happening as we're growing three-dimensional shapes. Remember too how we denote these. Linear scale factor is what we call R. Area scale factor is R squared. It's always R, and we just use R as like a variable to demonstrate it. So like our area scale factor is just our linear scale factor squared, and our volume scale factor we found out last Thursday is equal to our linear scale factor cubed. Okay, and what we can do then is, like, if we have one volume and we want to go to the bigger volume, we say, like, well, we know the volume, we might know a linear scale factor, and so we just multiply that volume by the linear scale factor cubed, and we can get our new volume, and we'll see that today as we practice it. So let's get into it. Okay, so in 9-53 here, a statue honoring Benjamin Franklin will be placed outside the entrance to the Liberty Bell exhibit in Philadelphia. The designer decided that a smaller, similar version will be placed on a table inside the building. The dimensions of the life-size statue will be 4 times. So the dimensions of the new statue are going to be 4 times that of the small statue. Planners expect that they'll need 1.5 pints of paint to coat the small statue. They also know the small statue weighs 14 pounds. And so the first question we're asked here, how much paint will it take to paint the life-size statue? Well, we know here that we have, just as like reading the problem, we have a linear scale factor equaling 4, because we know that the dimensions of the life-size statue are 4 times bigger than the smaller statue. Okay? Then we can actually, using that linear scale factor, we're going to be able to do parts A and parts B. Okay? For part A, it says how much paint will be needed to paint the life-size statue. Well, we know that they needed 1.5 pints of paint to paint the small one. We're going to multiply that by our linear scale factor squared. We're going to actually use our area scale factor here, because painting a statue, painting the outside of a statue, is talking about the area of that statue, the surface area of that statue. And so we're going to use that 1.5, and we're going to multiply it by 4 squared, because 4 squared is my area scale factor. Alright, so I need to multiply my original amount of paint by my area scale factor, and I'll be able to come up with how many pints of paint I'm going to need. Alright, and so what this turns into is, this is then 1.5 times 4 squared. 4 squared is the same thing as 4 times 4, and so this becomes 1.5 times 16, and when I multiply that out using my calculator, I get that that is 24 pints of paint. So we need 24 pints of paint to paint the big statue. Again, what I did is I just took that I needed 1.5 pints, and then multiplied it by my linear scale factor squared, because like painting a statue, you need to talk about area and an area scale factor. So I took my linear scale factor and I squared it, and then I multiplied the 2 and came up with 24 pints. It's a area scale factor. Now B is going to be a volume scale factor. Okay, so it says if the small statue is made up of the same material as the large statue, then its weight will change just as the volume changes. So we're seeing now, like, weight is related to the volume. And so if we're talking about a growth in weight, we're going to need a volume scale factor. All right, so then they're saying, how much will the life-size statue weigh? Well, we know the original weight was 14 pounds for the small statue. 14 pounds for the small statue. We have that linear scale factor of 4. So we're going to multiply by that linear scale factor. But because we're not using linear scale factor, we're talking about a weight which is related to volume, we're going to use the linear scale factor cubed, because linear scale factor cubed is our volume scale factor. Alright? And so when I actually multiply this out, I get 14 times 4 cubed, 4 cubed is the same thing as 4 times 4 times 4. And 4 times 4 times 4 gives me 64. And then 14 times 64 is going to give me my new weight. And that new weight is going to be 896 pounds for the big statue. I should use lbs because my word pounds looks really funny. But that's how much it'll weigh. All right. Again, what I did, I took my original weight of 14, multiplied it by my volume scale factor, which is my linear scale factor cubed. And I'm doing that again because weight changes as volume changes. Okay. And so I said 14 pounds was the original, multiplied it by my volume scale factor, got my new weight would be 896 pounds. All right. And that's kind of our idea here, just practicing. Hey, that problem said that we're talking about painting something. Well, painting is surface area, so let's use linear scale factor squared for area. This next one's talking about weight. Well, weight is related to volume, so let's use the volume scale factor, or the linear scale factor cubed. And we have to just kind of be evaluative of what we're doing here and what the problem's asking. So let's move into the next one here. We only have 2 more. And I'll probably be able to do this one in this video and then finish the last one in the second video. But let's see here. Blackbird Oil Company is considering purchasing 20 new jumbo oil storage tanks. Their standard model holds 12,000 gallons. Its dimensions are 4/5 the size of the similarly shaped jumbo model. All right. So what that part is saying there is that the jumbo model the standard model is 4/5 the size of the jumbo model. So it's 4/5 the size of the jumbo model. And that 4/5 is really going to be then our linear scale factor. If all the dimensions are 4/5 smaller, then that's going to be our linear scale factor here. And so then they're saying, in part A, how much more storage capacity would the 20 jumbo models give Blackbird Oil? What we have to find out first is how much can just one jumbo barrel hold? How much more can just one jumbo barrel hold? Well, we don't know how many gallons are in that jumbo barrel. And so what we do is we say, well, X amount of gallons, some number we don't know, is the amount of gallons that can fit into our jumbo model, okay? And we multiply that by our volume scale factor, okay? And we know our linear scale factor is the 4/5. So our linear scale factor, I'm gonna put this by A here. Our linear scale factor here is 4/5. And so here in part A, we say X amount of gallons for the big barrel. If you multiply that number we don't know by 4/5 cubed, so if you take your volume, the big volume that we don't know, and we multiply it by our volume scale factor, we should get our smaller volume, which is 12,000 gallons. Okay, so what this is saying is big gallons times volume scale factor gives me small gallons, or big volume times volume scale factor gives me little volume, because that 4/5 is telling me that that volume is going to be shrinking. All right, then I can actually calculate this out, and it's just like any kind of, that's multiplication there, so I want to divide. Let's do the next step here in saying that, well, 4/5 cubed is really 4 cubed divided by 5 cubed, which is 4 cubed is 64, and 5 cubed is 125. And that equals 12,000. All right, and that's still multiplication there. And so what I can do, and you could turn this into a decimal, I'm going to divide it as a fraction still. I'm going to take, to get x by itself, I'm going to divide both sides by 64 over 125. And that should give me x, which x is going to be my big volume. I have to do 12,000 divided by, and I'm going to put it in parentheses on my calculator, 64 divided by 125. And that gives me a volume, a big volume of 23,500 437.5 gallons. Which, again, it's nice to always reflect back and be like, does that number make sense? And to me it does, because if our small volume is 12,000, it makes sense that our big volume should be bigger. And so it's good to see a number that's bigger than 12,000. If you ever saw a number smaller than 12,000, you might have done something wrong. Okay? And so that's how many gallons are in the big one. But that's not what the question's asking. The question's asking, so how much more storage capacity would there be now that they bought 20 jumbo models? Okay? So my next step here is I want to figure out how many more gallons just one barrel can hold. So I'm going to take my new volume and subtract away my old volume. And so I'm going to say 23,437.5 minus 12,000. And again, I'm doing this division because I want to see how much more oil these new ones can hold. And so when I do this subtraction here, and again I got to bring up my calculator, 23,437.5 minus 12,000, I get that these new tanks, these new oil tanks, can hold 11,437.5 more. They can hold 11,437.5 more gallons than the old tanks. All right? But that's just one barrel. So one barrel can hold 11,000 more gallons, but we have 20 of those barrels, and so we have to multiply our answer here by 20, because we have 20 of those barrels, and each barrel is going to be able to hold that much more. And so we take our answer here, multiply it by 20, and by buying 20 of these large barrels, this company can now hold 228,750 more gallons. Or to answer the question a little bit better, to what the way they have it written, saying how much more storage capacity would they have if they bought 20 jumbo barrels? Well, they would have 228,750 gallons more storage capacity. All right, and so that's my answer right there. All right, the next one's a little bit shorter because we already have all the work for it. So in B, they're saying, let's go back up and read it. If the jumbo tanks cost 50% more than the standard tanks, all right, if the jumbo tanks cost 50% more than the standard tanks, which is a better buy? Well, I mean, we can look at these numbers and we can see that the small barrels could hold 12,000. The large barrel can hold 23,000, because where did we find this number? Right here, in the first part. We found out that the bigger barrels can hold that many more gallons. So 23,437.5, 23,437.5. And so this is really just becomes a conversation piece now. It's saying that the small barrel, which one's kind of the better bargain here if it costs 50% more to buy these large barrels? Well, this small barrel holds, the large barrel holds 2 times as much. It's pretty much like you could buy 2 small barrels and get just as much capacity as 1 large barrel. So a 50% price increase is nothing here. Think about if the small barrel cost, and this is just numbers, they didn't tell us this, but this is just numbers I'm going to come up with. If the small barrel cost $100 and a 50% price increase on that means the large barrel would cost $150. That's a 50% price increase. Okay? And what we're seeing here is for $50 more, you have double the storing capacity. Pretty much double the storing capacity for $50 more, or for just 50% price increase. And so the large barrel is definitely the way to go, because you would need to buy 2 small barrels to hold just as much as 1 large barrel. And if you bought 2 small barrels, that's $200. Where 1 large barrel, which holds the same as 2 small barrels, is just $150. And so you want to buy those large barrels. It's a better bargain. All right. We'll finish up 955 in the next video.